Hello, let's do the New York Times Hard Sudoku for February 26th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, the first thing I see is this 6 looking down into this box. That does place 6 in the box, and then that leaves a triple here, which is going to be 2, 4, and 9. And this sees the 4 and 9, so we get the 2, leaving a 4-9 pair. These two 6s do look down, this 6 looks in, so there's a 6 in one of these two. Anything else of note? Yeah, so this 4 looks up along with this 4-9 pair. So 4 is going to end up in one of these 3 cells. We do have 2 9s here looking in, and this 4-9 pair looks up, so there's a 9 in one of these two. This is full, so this 6 looks in, this 6 looks up. That puts a 6 in one of these two. That's going to point right. This 6 is going to look right. There's a 6 in one of these 3. Is there something with this 4, 6, 9 that's interesting? No, not really. 4s are interesting, actually. These 4s look in, this 4 looks down. So there's a 4 here. How about this 2, 5, 9? Well, we have 2 5s looking in. This 5 looks up, so 5's in one of these two. We have the 2s looking in as well. And this 2 looks up, so 2's over here. And then 9 is somewhere in here. Okay. What about the 1s? The 2 1s look down, this one looks down. Sorry, they look left. This one looks down. So there's a 1 here. The remaining digits in this row, there's 3 of them. They are 6, 7, 8. All right, I'm seeing this 6 down here, but otherwise I'm not seeing anything. But it does mean 6 is down here somewhere. And it does mean 6 is up here somewhere in one of these two. These 4 digits in this row are 3, 4, 7, 9. This sees 4, 7, and 9, so this has to be the 3. And then we're left with 4, 7, 9 here, but the 4 can't go in either of these, so the 4 goes there. And now we're left with a 7, 9 pair. All right. Over here, we do need 4, 6, 7, 8. This can't be 4 or 7, so this is 6, 8 only. This can't be 6, so this is 4, 7, 8. Oh, it's not 7 either. Oh, the 7 is placed in the box. I somehow missed that. So that's a 7. We're left with a 6, 8 pair here, and then this is a 4, 6, 8 triple. Don't need the corner marks anymore. And then over here, this will be a triple as well. I know it's 2 and 5, and then something else. 3, it looks like. Okay. This middle band did well. These two 4s look in, this 4 looks down. Oh, we already placed the 4. Never mind. This 8 looks in, this 8 looks down. That's not good enough. 9's not good enough. 6. Okay, I'm not seeing anything to do there. Let's look vertically. They got the 9's, the 1. Okay, 2 1's look down, so there's a 1 in one of these two. We've got 2 7's looking down, so 7's over here. What about 4, 6, and 9? The 9's are done. 4s, 6s. Okay, nothing there. We have 2 4s. We got that. We've got the 2 8s. Okay, this 8 looks in, so 8's up here. The 6s we got. All right, over here we've got 2, 4, 5. So the 2 4s look up, putting a 4 over here. And then 8 and 9. I'm not seeing anything to do with these. Okay, so what are we going to do now? Let's look for a restricted cell. So for example, in this column, there are only 4 open cells. So if there's 4 or fewer open cells in a row, column, or box, always a good place to look. Think about what digits are left. We need 1, 3, 5, and 7. So I'm seeing this sees 1 and 7. So this is down to 3, 5. I think this can be any of 1, 3, 5, 7. This can't be 5, so it's 1, 3, 7. And I only mark it if it's 3 or fewer. I don't think marking 4 is worth it in these puzzles. Some other puzzles it is, but not in the New York Times Hard. Which actually, it's the hardest the New York Times publishes, but it's not that hard. We needed what did we need? 1, 3, 5, 7? This can be any of those as well. Let's see here. The 2 looks in, this 2 looks in. I missed that earlier, but that does place the 2 and the 1 here, which is nice. So now we do have 2 2's looking up, so there's a 2 in one of those two. Let's think about this column. So we need 2, 3, 4, 8. So this can't be 2, 4, or 8, so this has to be a 3. And these are down to 2, 4, 8. This bottom one can't be 8. This is a triple. So what's left? We need 5, 7, 8 here. That's not 5. That's not 8. 5, 7, 8 means this can't be an 8. This is a naked triple. 5, 7, and 8. And I get questions about this a lot, so I'm going to go over this again. There's a difference between a hidden triple and a naked triple. I think with the style of my solve, you're going to find the hidden triples much more often. A naked triple is when you just see from penciling this. Like I penciled these cells just from, these are the digits they can be. That's it. Those are the digits they can be. So when we look at it, we see that the digits 5, 7, and 8 are the only digits that appear in these three cells. And we know that these three cells each need a value, right? So if we're not going to repeat any values between these, which Sudoku rules disallow, if we're not going to repeat any values, they're going to use up 3 numbers. 3 cells use up 3 numbers. What 3 numbers are these 3 cells going to use up? Well, they're going to use up the 5, 7, and 8. They don't have any other choice. There aren't any other digits that these can be just by looking at basic Sudoku rules, right? This can't be 1, 2, it can't be 3, it can't be 4, 5, 6. I mean, we can just look at the box, right? It can't be 1, 2, 3, 4, 6, or 9. And it also can't be a 5 for the row. So it's only going to be 7, 8. There's nothing else it can be without repeating in the row, column, or box. Same with this. This can only be 5, 7. This can only be 5, 7, 8. Those are the 3 digits that are going to end up here. If those 3 digits are going to end up here, then the rest of the column can't be those digits, right? Because we're going to have them in this column down here, right? Maybe I'll end up with 5, 7, 8 like this. Or maybe I'll end up with 5, 7, 8 like that. Or maybe I'll end up with, 5, 7, 8 like that. However it ends up, there's going to be a 5, 7, and 8 down here. So this can't be an 8, right? If this was an 8, how are we going to fill these 3? I could do 7, 5, and what? Another 7, another 5? There's nothing there. So we're going to break the Sudoku rules. So that's a naked triple. And this can't be an 8. None of these can be from 5, 7, 8. So we're just going to end up with another triple left over. So it's going to be 3, 4, and 6. And that's not a 6. Okay, hopefully that explanation will satiate people's curiosities. I think a lot of people just learn naked triple looks like this, right? They learn naked triple looks like this, 3 cells with 3 identical values. And if you don't understand why that works, then it's harder to understand why removing some of those options doesn't change the logic. But in general, in Sudoku, removing a candidate can't make the logic less powerful. It can only make the logic more powerful or stay the same. Eliminating a candidate cannot make logic worse. So you can always imagine more candidates in cells. And if that helps you see the logic, then so be it. You can imagine this could be an 8. You can imagine this can be a 5. And it's still a 5, 7, 8 triple, and it still does the same eliminations. But removing this 5 and 8 doesn't change that. So hopefully that's clear. Let me know if you have questions. I'll try to answer them in the comments if there are questions. Or make another video. All right, so with all that said, I've lost my momentum, but that's okay. I think that was important to explain. This row has 5 digits left. I don't know if I want to do that right now. This row has 4 left. We need a 4, 5, 6, 7. So this can't be 4, 5, or 7. Wait, it can't be 4, 5, 6, or 7. So no, it can't be the, okay. Good thing I checked that because I did that wrong. 1, 2, 3, 4. So 5, 6, 7, 9 is what's left. And this can't be 5, 6, or 7. So this is the 9. That's not a 9. So now in this box, the only place for 9 based on our corner marks, the only one corner mark left is here. Now that did use up a 4 corner mark, but there's still 2 places for 4, so we can't place it yet. But let's look at the rest of this. This is 5, 6, 7 now. Okay, well this one can't be 5, but otherwise I don't really see anything going on there. Okay, what else is happening here? How about this triple here? We need a 5, 6, 8, it looks like. Cleans up a little bit. Let's see. How about here? We need 1, 3, 5, 7. Oh, right. Yeah, these are ones I didn't pencil because they were just 1, 3, 5, 7. So I still don't really want to pencil them. That's one of the issues with losing your momentum is you lose that short-term memory of where you've looked and where you want to look next. So let's re-center ourselves here. What's a good place to look? I want to look at these 2 cells. They're avoiding the 4 and the 6. It's not actually that many that it's avoiding. This cell here sees 1, 4, 5, 6, 8, 9. Okay, so this can be a 2, 3. Can't be 4, 5. Could be 6. Could be 7. Can't be 8, 9. Darn, that is 4 digits. Okay, I'm not going to pencil that right now. I'm going to think about this column, which has 5 remaining. We need 2, 4, 5, 6, 7. 2, 4, 5, 6, 7. Well, this can't be 2, 4, 5, so this is only 6, 7. Oh, it's not 6 either? Where's the 6? Oh, the 6 is over here. Oh, okay. So this is only a 7, right? It sees 1, 2, 3, 4, 5, 6, 8, 9. So it's only 7. So that's an 8. That's not an 8. By the way, that is called a naked single, right? Because if you were to pencil every possibility that it could be, based on what just the Sudoku rules of what it can see, you end up with only 7. So it's nakedly a 7, just from looking at the candidates. This is 1, 3, or 9. Okay, the 9 ends up over here because it's not here. Okay, how do we follow up on some of these? We got the 7. So these two 7s look up, the 7 looks in. So that's a 7. And now we're down to 1, 3, 5 down here. We can mark that. 5, 7, 5, 7, 1, 2. What else can I do here? All right, these 4 digits are 2, 4, 5, 6. The 6 is not up here. So these are 2, 4, 5, right? 2, 4, 5. And these are 2, 5, 6 because they're not 4. Okay, that doesn't really help me. How about this column? We need 1, 2, 3, and 8. I'm not super happy about that. This can be any of them. This can't be 8. This is 1, 2, 3. This is 2, 3, 8. This is any of them. 2, 3, 5. Something going on here. All right, 8 in this row. I was looking at this 9 and 8 and seeing how they affected things, and I looked at this row and saw that the 8 was taking it out of all 3 of these, and then these also couldn't be 8. We had them marked so that it was easy to see. So even from our corner marks, we can see that. So this ends up the 8 for the row, which hopefully comes in handy. So now we're down to 1, 2, 3 here. 1, 2, 3, 5, 6. Okay, what's next? The 8 in this column, maybe? Not quite. 8 can go in 2 places. How about 9? 9 in this column. So 9's taken out of these 3. Oh, no. There's 2 places for 9. Darn. Okay, never mind. All right, what else can we do here? It feels like we're almost done. I just don't have the right thing penciled, I think. I'm looking to see if there's anything I've already penciled that I didn't notice. Okay. I'm not seeing anything. So I'm thinking about that just up here, there's going to be something. Let's look at the rest of this row. So we need 2. The 2 actually only go, oh no, the 2 can go there. Never mind. Okay, so let's just write it out. We need 2, 3, 4, 5, 6, and we have 7, 8, 9. Yeah, 2, 3, 4, 5, 6. That's not 2, that's not 4, that's not 4, 5. 2, 3, 6, not quite. There's an 8 one of these two. Let's mark that. Let's see. What about this column? We need 2, 3, 6, 7, not 7. There it is. This sees this 7. These 7s look in. And then this 7, oh, not that one. Yeah, this 7 looks in, sorry. And then these two 7s aren't 7 because they're filled. So 7 in this column can go here. 7 in this column can only go here. That gives us this 6 and also this 8 in the box. That's 6 and 8. We can place the 6 in this box. This is 5 and 6. 1, 3 pair tells us that's 2. This is 5 and 7. Right, we have a 2, 4 pair here. 1, 3, so that's a 5. Let's clean up a little bit now. All right, these aren't 5, these aren't 2. That's not a 5. Okay, so what's this, 1 or 3? Looks like it could be either. This is 2 or 3, could be either. 1, 3, 1, 3, 9, 2. 2-3 pair here, so that's a 4. That gives us the 2 and the 4 here. That gives us the 3 and the 2. That's a 3, 4, 6, 5, 8, and 2. Nice. That's 8, 4, and 6. We got the 1 and the 3. We got the 3, 5, and 2 here. We got the 1, 9, and 3. We got the 3 and the 1 here, or the 7 and the 9. 1, 5, and 7 remain. The 1 goes here. We get the 5 and the 7, and we're done. All right, well, hopefully that explanation of naked triples made sense, because I am consistently getting that question, so I feel like I'm not explaining them, which I really haven't been. I've kind of assumed that the logic was clear for naked triples, but hopefully that's helpful for those who've been confused as to how those can be triples. So there you go. Hope you enjoyed this, and if you did, then why don't leave a like, subscribe, and a kind comment below.